everyone, in this video we're going to focus on the effects of the parameters h and k on the graph of an ellipse. I would encourage you to watch the video that talks about how to graph an ellipse so you can get a better understanding on how these equations that we have here are graphed on this x and y axis, because in this video we're going to focus on the effects of the parameters h and k on the graph of an ellipse. So we're going to start with the graph of the first equation right here. Oh, by the way, in this slide, we're going to focus on the effects of the parameter h. If you notice, our k value remains all at 0. So all the k's here are 0. Well, if we look at the h value, we start with this value, the h. This is another h, this is another h, and this is another h. So we start with the first one here, so that we can go ahead and say that the center for this ellipse that we have here is located at 0, 0. And then our a value is going to be plus minus 3, because that's 9. Square root of that is 3, so that's plus minus 3. And our b here for this equation is plus minus 2, because the square root of 4 is 2. So that we can go ahead and sketch the graph for this letter A right here. So our center is at 0, 0. Then we go, the A is plus minus 3. The major axis is the vertical line. So that's going to be 3, 1, 2, 3 up, and 3 down, 1, 2, 3. And then the minor axis is along the horizontal line, which our co-vertex is located plus minus 2 from the center. So 1, 2, and then 1, 2. This is the graph of the equation that we have on letter A. So that's the graph of that ellipse right there. Now we are going to graph the second equation. So the second equation has this values right here. So we can tell that the center of this ellipse is, we switch the value of this negative 1 right there. So that would be at positive 1 and then 0. Again, there's another video on how to sketch the graph on this. I would encourage you to look at that video so you can better understand how we get these values. But then the center for this is at positive 1, 0. And then our a value is, again, that's going to be 9. So that's a plus minus 3. And then our b value is, that's going to be the square root of 4. So that's plus minus 2. So that, again, our center now is at 1, 0. So this is 1, 0. That's the center. And then we have up, down 3, because this is the vertex and it's located along the vertical line. So that's up 3 from the center. 1, 2, 3. And then we go 1, 2, 3. And then after that, these are the two vertices. And then we have the co-vertex is located to left and right from the vertex. So 1, 2, and then 1, 2. So this is where the co-vertices are located. So I'm going to sketch the graph of the second equation. So then this is the graph of the second equation. And then let's look at the third equation. So the center for this is located at switch and keep. So that would be positive 2 and 0. So then we can say that our a here is, again, the bigger number, which is 9. So that's plus minus 3. And the b is the smaller number, which is 4. So that's a plus minus 2. So then again, the center is at 2, 0. So this is the center right here. And then we go, since the major axis is the vertical line, so then we can go ahead and say we go up, down 3, 1, 2, 3, and then we go down 1, 2, 3, and then the co-vertex will be located left and right 2 from the center, 1, 2, and so that's going to be 1, 2, so it's going to be right here. So we can sketch the graph of the third equation. Looking at this, we can tell that the effect of h on the graph is that it moves the graph to the Right. So originally the graph was located right here, and then it moved to the right one step each because the center was moving one step as well. Now let's see how the other graph look like. So let's have here this fourth equation. So our center here is switch and keep. So that's going to be -1 and 0. Again, our A is plus minus 3 and our B is plus minus 2. So center is at -1, 0 right here. And so we go up 3, 1, 2, 3, and then down 3, 1, 2, 3, and then 2 to the left and right. So 1, 2 to the left and right. So this is where the fourth graph would sit. So I'm just going to go ahead and draw that fourth graph right here. And let's graph the last one here, which is E. So again, the center for this is switch and keep. So that would be -2, 0. Our A here is plus minus 3, and the B is plus minus 2. So that we can go ahead and say that it's at -2, 0. And then up, down 3, 1, 2, 3, and then 1, 2, 3, and then left, right, 2, 1, 2, and then 1, 2. So we can go ahead and sketch the fifth ellipse right here. And this is the fifth ellipse here. So that represents the fifth equation. Now, I would like you to notice this very carefully. We started with a graph located at the point of origin. Now, we started changing the value of h. On the first two here, the graph moves right. So starting with the red, it moves one step right. And then with the blue graph, which is represented as letter C, it moved 2 places to the right. Now, on the other hand, from the point of origin where the original graph is, we draw the fourth graph, which is the letter represented as letter D right here, green. And then it started moving to the left. And the purple graph right here represented as letter E. It also moved to the left 2 places. We can therefore say that the parameter H moves the graph left or right. Now let's investigate the effect of K on the graph of an ellipse. Okay, looking at the equation here, our H value for all of these equations that we have here would be 0. So all H here would be 0, but notice the K values have been changed. So let's see what will be the effect of K on the graph. So let's start with the first one. So we can go ahead and say that the center for this ellipse is at 0, 0. So I'm just going to write that as 0, 0. Our A value here would be the bigger number, and we get the square root of that. So that would be plus minus 3. And then the B value that we have here is the square root of 4. So that would be plus minus 2. So that we can go ahead and tell that our major axis is the vertical axis. So that is from the center. And then from the center, we count up, down 3. 1, 2, 3. And then we go 1, 2, 3. So then we can go ahead and do the co-vertex. That's going to be on left, right, 2. So that's 1, 2, and 1, 2. So this is our co-vertex, and that's the second co-vertex here. So we can go ahead and sketch the ellipse for letter A. So this is the first ellipse. Again, our center here is at 0, 0. Now let's look at the second equation right here. So in the second equation, our center is, again, we remember it's 0. So that's 0, and then switch. So that would be a positive 1. So that we can go ahead and say that our A is plus minus 3 and our B is plus minus 2. And again, the vertical axis is our major axis, since 9, the bigger number, A, is located below the Y. So that we can go ahead and say that our center is at 0, 1. So that's the center right there. And we count up, down 3. So 1, 2, 3. And then 1, 2, 3. And then this B will determine the covertex located at that's gonna be left, right, 2 from the center. So 1, 2, and then you go 1, 2. So this is the graph of the second ellipse represented by the second equation, letter B, right here. Now let's look at the third equation. So I can go ahead and write the value for C, A, and B for this equation. Okay, so I've drawn the third graph right here represented by this third equation. If you notice, we started at the point of origin. Now the ellipse started moving up. So this moved 1 step up from the point of origin. This moved 2 steps up from the point of origin. Now let's see the fourth graph right here. So this is represented by this equation down here. So I'm just going to go ahead and write the center. So the center for this is going to be 0, and that is switch. So that's -1. And then our A is plus minus 3, and our B is plus minus 2. So the center now is at 0, -1. So 0, -1, that's the center of the fourth ellipse. And then we go up, down 3, 1, 2, 3, and then 1, 2, 3. So that we can go ahead and do the covertex, 1, 2, and then 1, 2. So we can go ahead and sketch the ellipse right now. So that's gonna be 1, 2, 3. So it's up here. And so now if you notice, the ellipse started to go down from the point of origin. Now let's draw the fifth ellipse right here. Okay, if you notice, the ellipse now is moving up for the first two equations from the point of origin, and it's moving down for the next two equations right here from the point of origin. We can therefore say that the effects of the parameter K to the graph of an ellipse is that it moves the graph, or it moves the ellipse up or down. So to wrap it up, the parameter H moves the graph left or right, while the parameter K moves the graph up or down. Now let's look at the Desmos version on the effects of the parameters H and K on the graph of an ellipse. In this video, we're going to determine the effects of the parameters H and K on the graph of an ellipse. We remember that the standard form of an ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared. Now please remember that the values for a squared and b squared can get switched. It depends on what case of ellipse we're talking about. So in this equation that we have right here, since our a is always greater than b, we can therefore say that the major axis for this standard equation that we have here is the vertical axis, since a is under the y variable up here. So we can go ahead and equal this to 1, and we add all the sliders h, b, k, and a. And so we set our a to 9. So I'm just going to go ahead and change this to 9 right here. And we are going to set our b to 4. So I'm just going to go ahead and change this to 4 right here. So this is our ellipse. Now again, the purpose for this video is to determine the effects of h and k. As you can see, if I change the value of h to positive, it moves the ellipse to the right. Now if I reduce the value of h, it moves the ellipse to the left. Therefore, we can say that the effects of h on the graph of an ellipse is that it moves the ellipse either left or right. Now let's look at the effects of k on the graph of an ellipse. So if I change the value of k here, that moves the ellipse up. And if I do it the other way, I reduce the value of k, then that moves the ellipse down. We can therefore say that the effect of k on the ellipse is that it moves the ellipse up or down. So these are the effects of h and k on the graph of an ellipse. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!